Sometimes when we're looking at fractions, we want to compare them to see which is bigger. For example, I might ask you, would you rather have 1/2 of your favourite cake or 1/4 of it? My cat has joined me as per usual for the videos. Hello, Nala. Well, you might say to yourself, a half or a quarter. Well, if you looked at the half and the quarter, then you might think, well, the 4 is bigger. So I'll have one of those, please. But of course, anyone who's really cut a slice of cake before would know that if they cut a cake in half, like this, they would get quite a lot more than if they cut it into quarters. Because as we saw with our other video about what fractions are, the denominator, the bottom number, says how many parts we have. The more parts I've cut it into, the smaller each part's going to be. So for me, about my favourite cake, I'd always rather have half of it. But of course, wouldn't eat it all at once. This one here then, this is what we call a bar model. It can help us to see fractions. I'll use a few of these so you'll see what I mean as we go along. So if I had an example like 2/10 and 1/2, well, you might say to yourself, that 2 is larger, so it must mean that that's bigger. Well, that's not quite the case, and using a bar model like this can help you to see why. So it's 2 separate bars. This top bar, I like to think of a chocolate bar to help remind me, it's literally just a bar split into chunks. This top one, that's a whole altogether, and it's been split into 10 pieces, which means that each one is 1/10. Look back at the video on what fractions are if this is not making sense. So if each one of those is 1/10 and I'm trying to show 2/10, I would colour in 1, 2 of those. Now underneath I've got a bar exactly the same size, but this time it's split into just halves, so I can compare whether the bar when it's split into 2/10 is bigger or smaller than when it's split into 1/2. So if I was to look for one of the halves and colour that in, I can have a little look at which is bigger. Hopefully you can see that the yellow, the 1/2, is a lot bigger than the 2/10. So I would write that 2/10 is less than 1/2. Let's look at some more examples. So I could have 2/4 or 3/8. If I wanted to colour in my quarters, I'm doing 2 of those, so I've got my 4/4 there, and I'd go, there's 1/4, there's another quarter, so there are my 2/4 in green, and then over here I want to look at my 3/8, 1, 2, 3, and I can compare them and see that the green section is bigger than the yellow one. The green goes all the way up to there, the yellow only goes to there. So there is more when I have 2/4 than when I have 3/8, which means that 2/4 is greater than 3/8. Here's another example. We've got 3/8 starting with this time, so 1, 2, 3/8, because I've got 8 pieces altogether and I've coloured 3 of them, so that's 3/8. Or I could have 4/5, so 5 altogether, and I colour 4. You may have even been able to guess this one, but the 4/5 is a much bigger chunk than just the 3/8. So my 4/5 is the one that is larger, so 3/8 is less than 4/5. But sometimes you might want to do it just using your head, not using a picture, or just writing down a method rather than doing the bar models. So you could use some times table knowledge. You could have a think about what 2/4 is and 3/4 and which one is larger. But to really compare them properly, the denominator has to be the same, because otherwise it's not fair. If I'm thinking about quarters, they're very different to eighths. They're a much different size. So I can think about it in terms of the same denominator. If I make them both 8, like this, then I'll be able to compare them. 3/8 will stay the same. But for 2/4, if I'm doubling that 4 to give me 8 at the bottom here as the denominator, I have to do the same to the top. So 2/8 would be the same as 4/8. We'll look another time at how you do that sort of thing, but this is how I would change them to make the denominators the same. Once they're the same, I can see which is bigger. 4/8 is going to be bigger than 3/8. My 8s are now all the same size, so I can keep them equal, but the 4 is bigger than the 3. So 4/8 is bigger, greater than 3/8. And then it means that I can now know that that means the same thing for this, that 2/4 would be bigger than 3/8. Let's look at that again. So here's another example. This time I've got 2/3 and I've got 3/6. So I'm thinking to myself, well, how can I make those denominators, those bottom numbers, the same? Well, I could use 6 because 3 will go into 6. So I start by seeing whether one will go into the other. 3 does go into 6, so I can have 6. 3 6 will stay the same. But if I'm going to change my 2/3 to be 6ths, then I need to look at what that means. The 6 has been doubled from the 3, that's 3 doubled, so I need to do the same on the top, which means that my 2/3 has changed to 4 sixths. And I can see 4 6 is bigger than 3 6ths, which means that it works the same at the top. Let's look at one final example. Now here, it's slightly different because when I look at my numbers, 3 doesn't go into 4 and 4 doesn't go into 3. So we need to find what we call a common denominator. What that means is a number that could be a denominator for both of them, even though it won't be either of those numbers. So I'm looking for a number that 4 goes into and that 3 goes into. Well, if I think of my times tables, a good way of doing it is to say, well, 4 times 3 is 12. So 4 goes into 12 and 3 goes into it because it's 4 times 3. So I could use 12. So if I was changing 3/4 into 12ths, then to go from my 4 to my 12, what I've done is I've times by 3. So I've done 4 times by 3 is 12. The rule is I must do the same on the top. So then I do 3 times by 3, which gives me 9. So 3/4 is now 9/12. Now over here, I want to have 12ths at the bottom, but I'll be doing it slightly differently because to get from 3 to 12, I've had to times by 4, which means that I'm doing the same up there to the top. I've gone 1 times 4 here, which is 4. So now what I know is that 1/3 is the same as 4/12, 3/4 is the same as 9/12. So now I've got 9/12 and I've got 4/12, and so I can see which is bigger. They're both the same at the bottom now, which means all I need to think about is whether 9 is larger or 4. And 9 is the bigger one, so I say 9 is greater than 4, which means that my 3/4 is greater than 1/3. Now, if that's new to you, it might take you a while to get your head around, so maybe watch again and just see if you can work it out. I will be doing another video to go into this in a bit more detail if you're not sure, so you can have a watch of that if you're not sure. But the thing to remember is that when you're comparing fractions, you need to make sure that you get the denominator so that it's the same. And sometimes that will mean doing some times tables to change them. Good luck!